So, today my lecture will be about structure of atom. The basic contents which I will cover in today's lecture will be defining atoms, the subatomic particles of the atom, the electron shells and the arrangement of electrons in the shells, then proton number and definition of proton number and mass number, and lastly we will understand what are isotopes. So, here I would like to show you the basic structure of atom. Here I gave the example of helium. Its proton number is 2 and its mass number is 4. Helium, its chemical symbol is He. On the lower side it is written the proton number, and at the above side here it is showing 4 is showing the mass number of helium. It means proton number 2 means that helium has 2 protons and these 2 protons are present in the nucleus, while 2 neutrons are also there in the nucleus. So, 2 plus 2 4. That is why the mass number of helium is 4, which here it is written. So, here there are 2 protons and 2 neutrons, while 2 electrons are revolving around the nucleus. So, basic structure of atom is that nucleus is the center of the atom, and in this nucleus there are protons and neutrons, while electrons are revolving around the nucleus in certain orbits. Definition of atom. So, an atom is the smallest particle of atom that can exist independently. The word atoma was coined and was firstly used by Greek scientist Democritus, which means indivisible. However, now we know that atoms have smaller subparticles such as protons, neutrons and electrons, and an element is made of same kind of atoms. For example, if an element is gold, for example, if the element is, let us take the example of iron, these are the two metallic elements. So, if we are talking about only gold, so all the atoms of gold will be of similar kind, will be of similar type, their size, their atomic structure, their proton number, their color, their density, all will be equal, all will be similar. Similarly, if we are talking about the element iron, so in iron we will find that all the atoms are similar. Similarly, hydrogen or oxygen, so hydrogen is another element. So, in an element all the atoms are similar. Element is made up of same type of atoms. Subatomic particles of the atom. Atoms are comprised of further smaller particles, subatomic particles. They are mainly protons, neutrons and electrons. So, this table is showing some detail about these fundamental particles of atom. Proton, its symbol, it is represented by small p, proton, and its mass is 1 and its charge is +1. Remember that proton is a positively charged particle, P for proton and P for positive charge. And on the other hand, neutrons, which it is represented by the symbol N, and its mass is 1, but it is neutral particle. Neutron for neutral, it means that it has no charge, zero charge. Here we can see in the table it has zero charge. And the third subatomic particle is electron. Its symbol is E and its mass is 0. Remember, at this point I would like to make it clear that protons and neutrons are the two particles which have some mass. Relative mass of proton is 1 and the relative mass of neutron is 1, whereas electron has no mass. Its mass is so much small, it is so much small that we can say that it is negligible, we can say that it is 0. While on the other hand, in terms of charge, electron has a value. Its charge is equal to proton but opposite to proton. Like proton has +1 charge, so electron has -1 charge. So these are the some basic details of the subatomic particles. Now come to the definition of proton number. Proton number is the number of protons. What is it? It is number of protons in an atom of a particular element. So proton number is the identity of an element. For instance, if I say hydrogen, so its proton number will be 1. If it is helium, its proton number is 2. Lithium has proton number 3. If it is 4, it means it must be beryllium, nothing other than beryllium. If it is 5, it is nothing other than boron. Because, and if the proton number changes, the element changes, like the roll number. If the roll number, the students are identified by the roll number, similarly the elements are identified by their proton number. Every element has a specific proton number. Now come to the definition of mass number. Mass number or nuclear number. We can define the mass number, or the other name of mass number is nuclear number, as the total number of protons and neutrons in an atom of an element. Remember, as I mentioned in the previous table, that these are the protons and neutrons which determine the mass of the nucleus, because electrons have no mass, 0. So the mass of the atom will be decided and will be determined by the protons and neutrons. So that's why the mass number, while considering the mass number, we will count and we will consider the number of protons and neutrons in an atom. So the total number of protons and neutrons in an atom of an element, this is called mass number. For example, if I am talking about lithium, so lithium has, if I am talking about lithium, so lithium has 3 protons and 4 neutrons in the nucleus. It means it has total 3 protons and 4 neutrons. So 3 plus 4, 7. That's why its mass number will be, its nuclear number will be 7. On the other hand, obviously the proton number of lithium is 3. Why its proton number is 3? Because it has only 3 protons. So that's why its proton number will be 3, but the mass number will be 7. 3 plus 4, 7. 3 protons and 4 neutrons. And remember that the electrons are always equal to the number of protons. Whatever is the proton number of an element, the same will be the number of protons and the same will be the number of electrons. Protons and electrons are always equal. If an element has 3 protons, it has 3 electrons. if an atom of an element is having 4 protons, for example beryllium, it will be having 4 electrons. If let's take the example of oxygen, its proton number is 6, it means it has 6 protons and 6 electrons, and so on. And these electrons, they revolve around the orbits, in certain orbits, in certain paths or shells, like, and let me tell you something more, that in the first orbit of the atom has the maximum ability and capacity to hold 2 electrons, not more than 2 electrons. And the second orbit has the capacity to hold 8 electrons in total. However, for example, in this particular case of lithium, there are total 3 protons. So how these there are 3 electrons. So how these 3 electrons are being accommodated, that first 2 electrons are present in the first shell and the third electron will go to the next shell. So this is basic structure of an atom. Here we are taking the example of lithium. Now, as I mentioned, that proton numbers are always equal to the electron numbers, number of protons, number of positive charges and number of negative charges, number of protons and number of electrons in an atom are always equal. Originally, before the bonding, every atom is neutral and it has equal number of protons and electrons. And so here I would like to mention that number of proton number is equal to the number of electrons, and if the proton number is mentioned, it means we can also deduce that how many electrons it will be containing. And if now we know that how many electrons are there, so electronic configuration is, what is the electronic configuration? The arrangement of electrons in the shells of an atom. Let's start from hydrogen. Hydrogen, its proton number is 1. So it means it has 1 electron, and this 1 electron is present in the first shell. Helium, its proton number is 2, and it means that it has 2 electrons, and these 2 electrons are present in the first shell. Then lithium has 3 protons and it has 3 electrons. Now these 3 electrons, the first 2 electrons will be present in the first shell, but then we will put the comma and then we will write 1. It means that another electron, the third electron, will go here in the second shell. Then beryllium, its proton number is 4. It means it had 4 electrons. So 2, 2. Now the second shell is filling. Now the 2 electrons are present in the second shell. Then boron, it's 3 electrons in the second shell. Carbon is having 4 electrons in the second shell. Nitrogen is having 5 electrons in the second shell. Then oxygen is having 6 electrons in the second shell. Fluorine is having 7 electrons in the second shell. Neon is having 8 electrons in the second shell. But now, as I told in the beginning, that the second shell is having the capacity to hold maximum 8 electrons. Now if an atom is having 11 electrons, so how they will be arranged? What will be its electronic configuration? Suppose in case of sodium, its proton number is 11. So it means it has 11 protons and 11 electrons, and how these 11 electrons will be accommodated, will be arranged in the shells? 2 electrons in the first shell, then the remaining 8 electrons will go in the second shell, and now 1 electron is left, and this 1 electron will go in the third shell. And then if we are talking about magnesium, so here now instead of 1 there will be 2 electrons. If then we are talking about the next aluminium, so 3 electrons, 281, then 282, then 283, then 284, then 285, then 286, then 287, and the electrons keep on filling. As more and more electrons are coming in the next element, in the next atom of the element, so the shells are filling. So this is about the electronic configuration. Next is the concept of isotopes. Atoms, we can define isotopes that atoms of the same element having similar proton number but different number of neutrons or different mass number, different nucleon number. It means that isotopes belong to the same element. The elements are same, but what is the difference? The difference is in the number of neutrons. If it is same element, so number of protons will be same, number of electrons will be same, orbits will be same, chemical behavior will be similar, will be same. The way they react, it will be similar. But what will be the difference? The difference will be in the different number of neutrons. So let us take the example of hydrogen. Hydrogen has 3 isotopes. So the first isotope, suppose it is called protium. Why it is called protium? Because it has only 1 proton. So that is why the scientists named it protium, because it has only 1 proton, but it has no neutron. As we know that hydrogen is the element which has proton number 1. So it will be said, it will be called hydrogen. Similarly, this is another type of hydrogen, but it is also having 1 proton, so it will be hydrogen. This is also hydrogen, it is also having 1 proton, 1 proton, 1 proton, 1 proton. Similarly, this hydrogen is having 1 electron, 1 electron, 1 electron. Same orbit, 1 orbit, 1 orbit, 1 orbit. But now what is the difference? The difference is that this most common hydrogen, it is having no nucleus, no neutron in the nucleus, no neutron, 0 neutron. But this one, this is another type of, another isotope of hydrogen, it is having 1 neutron. And this is another isotope of hydrogen, another type of hydrogen, it is having 2 neutrons. So difference is in the number of neutrons. This hydrogen has 0 neutron, it is having 1 neutron, it is having 2 neutrons. This is the difference. Despite of the fact that all these 3 are belonging to the same element, despite of the fact that all these are hydrogen, despite of the fact that all these are having same number of protons and same number of electrons and same shells and similar chemical behavior and similar type of bonding, similar chemical properties, but the difference is in the number of neutrons. This specific hydrogen has no 0 neutron, that is why, and it has only 1 proton, that is why it is called protium, it is named protium, and it is having 2 particles, 1 proton and 1 neutron, this one, this isotope of hydrogen, that is why they name it deuterium, deuterium means 2, and this one they named it tritium because it has 3 particles, subparticles, 1 proton and 2 neutrons, so 3, tritium. Proton number is same, 1, 1 and 1, but the mass number, nucleon number is different. Here its mass number is 1, but its mass number is 2 and its mass number is 3. So this is the concept of isotopes. Let me give you another example to understand the concept of isotopes. Let us say if I am talking about a fruit, apple. So apple is one type of fruit, grapes are a different type of fruit, mango is different, another type of fruit. But if we are talking about apple, but there are different varieties of apples. One type of apple is called, suppose black one, or one green, or any other species. Or if I am talking about another type of another fruit, for example grapes. So grape is one type of fruit, but it has so many varieties, like so many, that like red globe, like Alfonso, like many other type of, you will find different type of grapes, different varieties, different colors, different taste, but the fruit will be same. Same is the concept with isotopes, that isotopes are atoms, they belong to same element. Like there are so many isotopes, like there are 3 isotopes of hydrogen, there are 3 isotopes of carbon, there are so many, there are 2 isotopes of chlorine, and so on. Their proton number is same, the element is same, but it has number of neutrons are different, and due to the number of neutrons the mass number is different, and due to the different number of neutrons the physical properties are different, density is different, boiling point is different, melting point is different. However, chemically they are same, chemically they belong to same element. Their chemical behavior and the way they bond with another element, chemical properties, they are similar. This is the concept of isotopes. Thank you.